Good evening, all. Okay, so we will be starting the next session, right? The day session number 9, right? In the last session, we discussed about some few of the commands, right? So today we'll be getting into few more commands, okay? And what we will do, like we will try to get into the scripting part, so which is very important. Okay, so I would expect minimum another 6 more sessions on Linux, actually 6 to 7 more sessions. So we will be continuing even the next week also. Okay, so tomorrow, as you know, guys, tomorrow I'll be having a morning. I have some work, so afternoon I'll take the class, and the evening we'll have Git class. Okay, so again the same thing. Sunday morning again 10:30 we'll have a session Linux, and again in the evening we'll be having the Git session. We'll continue the Git. We'll try to finish the Git. Okay, Git again I need 4 more sessions to complete. Okay, fine. So we were executing some commands actually, right? And today we'll be continuing to learn some more commands. Okay, like what are the commands? Like for example, in the last class we had learned about the ps command, right? ps -ax pipe it to less. So this will show all the process which is running in your Linux machine. If I execute ps-ax pipe it to less, so you know, right? These are the information about each and every process which is running in your system. So there are many processes are there which are running in your system. And as we discussed, right, what is a process? A process is nothing but it is a running instance of a program in memory. We call it as a process, or a program in execution. We call it as a program process. Program in execution. We call it as a process. So each and every process, each and every process will have the PID, process identification process identification number. Okay, so each and every process will have a PID, process identification number. And uh, always the first process which is created in Linux or in Unix is the init process, and the PID of the process is always 1. The PID of the process ID is always 1. Later, all other process which are created are child processes of init itself. So init is the one who's going to create all the child process. So what are the process which you are seeing right now here? Everything, all these processes are the child process. It means that it always be a child of the init process, we say. Okay. Now you could see that actually there are many processes are there which is having a with the name which starts with the name K thread actually K. So these are all the kernel process or the K thread D process. These are all the very, very important processes. Okay, like case of IRQD, K dump D, K swap D, like that. These are all the kernel process or kernel threads. So all these processes, if you see, right? So here, if you see, right, there are 4 columns are there. 1, 2, 3, 4, 5. 5 columns are there, sorry, in this the entire output of ps-ax command. The first column is the PID. That's what I'm saying. Every process will have a PID. So, or it's a number. So this is the PID of the process which is running. Okay, these are the PIDs assigned by the system, and this is nothing but the terminal under which terminal the process is running. Wherever you are seeing anything as a question mark, it is nothing but those are daemon processes or daemon, we say. Daemon or daemon processes. Basically, daemon processes are those processes which are running in the background. Okay. Process which are always running in the background, and process which is an orphan process. It means that those processes which doesn't have any parent, we call it orphan process. Okay, so daemon are okay parentless processes, or it is a orphan processes, right? And daemon process, one of the other characteristics of the daemon process is that daemon processes, daemon processes or daemon processes are not attached to any terminal. So you could see here many of the processes having question mark. Those processes are daemon processes. It means that all these processes are not running under any terminal. They are actually attached to a terminal. Like for example, if I execute a command, yes, hello, and say enter, this process is continuously running, right? If I open one more terminal, if I execute ps-ax and enter, can you see that this process is running? S hello is running, and it is running. It is having a PID 3315, and you know it is the this is the terminal under which it is running /dev/pt/0. So under this terminal name is PID. Sorry, this terminal name is /dev/pt/0. It means that this hello s, right? Yes hello. This is a recursive process which is running continuously, and it is using the terminal pt/0. It means that it is working under some terminal. Here it is showing as a sleep. So here the second column represent under which terminal the specific process is running. So here what happened, right? You could see some process are running in the TTY1 terminal, some process is running on the TTY0 terminal, some process are running in the PTS0 terminal, right? Like that way, it will keep showing you the terminals. So the second column represent in under which terminal the process is running. But you could see the many processes are there which are actually having question mark, mean that those processes are not attached to the terminal. Those processes are running in a background. Those processes are kind of a daemon process. You cannot kill those daemon processes. That's what I want to say. You cannot kill the daemon processes. Now what is happening that if you execute the ps-as in the other terminal, it should show that this s hello process is running. Let me do one thing. Let me run one more time. So you could see that it is showing you some PID. You can kill that process. You can kill the process with the help of a kill command. If I execute kill -9 and specify the PID of this process 3315, so kill command will forcibly kill that process. See, it has killed the process. So kill -9. This -9 is one type of signal. We call it the sig kill signal. Okay, so if we want to see what are all the signals which are there in the system, right? If you can execute kill -l command, if you execute kill -l and say enter, you could see that there are 64 signals are there. So there are in Linux, there are 64 signals. Okay, out of which the signal number 1 to signal number 35 or 34, these are normal signals actually. 1 to 34 signals are normal signals. Above from 34, like 35 to 64, these are real-time signals. So right now we are not dealing with any kind of a rest from 35 to 64. No, we are not dealing with all the signals. We are only dealing with the signals from 1 to 34. These are the signals which we are dealing. Okay. Now when I executed the command kill -9, again I'll run this process s hello. It will continuously, it will be printing this hello hello string into the standard output. So it means that I'm making a process to run. Again, if I execute a command ps-ax and say enter, you could see that actually yes hello, it is having a PID 3366. So I want to kill the process, means I will say kill -9 and say 336. Okay, so what you're doing now, you are sending a signal number 9 to this process PID. So what is the signal number 9? If I do a kill -l, you could see that every signal has some number. Like signal number 1 is sig up signal, signal number 2 is sig in signal, signal number 3 is sig quit. Like that, you have a signal number 9, which is nothing but a sig kill signal. Sig kill will forcibly kill any kind of a process. If the process is busy, if the process is not able to proceed further, if the process is continuously it is running in the system, okay, it is not getting stopped for some reason, then a user can use this signal to kill that process forcibly. So what happened, right? When you are generating or when you are sending the signal to that process, signal number 9, then that signal will forcibly kill that process. So here, when I do a ps-ax, enter, and if you see, this is the process 3366. When I am sending the signal number 9 by using the kill command with the -9 option, if I am sending the signal number 9, what happened, right? What the kill command will do? Kill command will forcibly kill this process with the help of a signal number 9. Signal number 9 is sig kill. It will forcibly or it will abruptly kill that process. It means that whatever the state the process that, it will forcibly kill it. It will not even allow the process to restore or do something. No, it will forcibly kill that process so that the process will get killed successfully. So this is a very dangerous process, sorry, dangerous signal we say, because usually in many places, particularly in production environment, right, you are not allowed to kill any process forcibly like that. But sometimes it happens that they want to kill it, the process forcibly, then they use the kill -9 signal. Okay, so that's how. Now here again, when you come back over here in this terminal, so the process got killed. Again, I'll try to run a yes hello. You could see that the process is continuously running. Many times what happened, the your terminal will be occupied by some process which is running actually, and you don't want to continue with that. You said that, Rajesh, I want to kill this kill this terminal, kill this process man, which it is just occupying my terminal. So then what you do, you will say control C. Control C also will kill that process actually. So in that case, when you are doing a control C as a user, what you're doing through your keyboard, you're actually generating a signal, and that signal is a sig int signal. Sig int. Whenever I say control C, so it means that it is actually internally generating a sig int signal. Sig int general sig int signal will also kill that process. Will kill that process. Similarly, you have signal number 19, sig stop. It means that you want to stop some process which is running. Take, for example, same, yes, hello, I will be running this process. This process is continuously running. Now I will go to the other terminal. I will say psax command. I want to know the PID of the process and enter. You could see that this process is having a 3381. You could see that every time you are getting a new PID, right? Because like as soon as a new process are getting created by the system, of course, what happened, your kernel or your process management part of your kernel, that will assign a new PID for the newly created process. So here in this case, it has created a process ID 3381, right? So when you see this process is running, what you can do, right? You need to stop that process. There are two methods you can stop the process. Either you can send a signal number 19 to that process, right? For example, if I execute ps-ax, enter, and you have a PID 3381, I can say kill -19, because 19 is the signal. What is that signal? Sig stop signal, and specify the PID of the process. You can either send a, so what this will do, it will send a signal number 19 to this process 3381. Signal number 19 is sig stop signal. It means that you are actually making the process to stop, not to kill, just to process to stop. Or either what you can do, you can come over here. You have a shortcut to generate the sig stop signal in your with your keyboard itself. So what is that? You have to say Control Z. Control Z will stop that process. And what happened, right? It will make the process into be in a queue. So when I stop this process, again I'll come back to this terminal. Again, if I execute the command psax -ax, ps space -ax, and say enter, can you check the process has been now stopped? P means it is in a stop state actually. Now again, what happened? You come back to this terminal. There is a command fg, or you can sorry, not fg. There is a command the jobs command. If you execute the jobs command, can you see that it says that it is in a queue actually? It says that this process is stopped, and the process job number or job ID is 1 actually. Again, you can make it to rerun the process by using a fg command. Fg is foreground space, specify the job ID 1 and say enter. Now you could see that process again starts running. So what happened, right? Here you have a different states of the processes. What are the different states of the processes? Some of you already know it. What is that? The process is in a running state. The process is in a sleeping state, or we call it as a interruptible sleep state. Interruptible sleep state, we say. Interruptible sleep actually. The third is a the process in a stopped state actually. And the process is, but some process will be an orphan process actually. Orphan. Some process state will be a zombie process, and some process will be having a Daemon process actually. So these are the different states of the process. This we call it Daemon, or we can call it the even defunct also. Defunct state. And always the states of the process, it will always be like, always the process is nothing but it will be R. And you could see that actually this process will be in S, capital S. This process will be in a stopped actually, and you know that for the stop process, it will always be, it will be having a something like, it will be having a T actually. T means it is a stop state. Orphan, O actually, O process. O. I think I did a mistake actually. Zombie process are not but defunct, not the Daemon actually. I'm sorry. We can call it as a zombie process as a defunct process also, and this will always be Z actually. Yeah. Daemon, Daemon process, basically it will be a the state of the Daemon process will always be, stat will be Daemon process. Wait 1 second. Z means zombie process, defunct process. T means stopped. Okay. D means D only. It will be D only, sir. It will be D only. Daemon process state will be D only. So if you execute the man page, man of PS, manual page of PS, man of PS, you can see that states of the processes like this. Come up, come up. I went to the last page of the man page. Then just I'm scrolling up actually. Here somewhere you will see the states of the processes. Sometime they might ask in an interview, what is a zombie process? Can you tell about what is, how you say a process is a zombie process? Like that. So these are the state, process states, code actually. Okay. Now, sir, is it till here? Are you clear, sir? Till here, are you okay? Are you clear? Or I mean, still I have not yet explained anything, but you have any doubts till here? If no, I'll proceed further. Okay. No. Okay. So now, so here, what is happening that this process is continuously running, fine, and you could see if you execute the command psx command, you could see that the process is actually running, but it is showing as a S. S means sleep actually. Foreground. It means that this process is not actually running. It is going to the sleep state actually, but it is not going to sleep state. It is continuously running because whenever I'm executing this psx, right, at that time it will showing a sleep. Because in the fraction second what happened, the process will go to sleep, again it will wake up, again it start running, again it'll be going to sleep state. So what happens that there's a scheduler, right, in a system, in a kernel there's a scheduler actually. So there is a scheduler by name, there are many schedulers are there. Now the scheduler is priority based preemptive scheduler, is a scheduler which is running priority based preemptive scheduler. So this scheduler will be keep scheduling the process in a system actually. Priority based preemptive scheduler. Even we have a round robin scheduler also. We are having round robin scheduler also, like that. And we have a, now we are having a scheduler. I have forgotten the scheduler name. Completely fair scheduler. Completely fair scheduler. We call it as CSF. So this is the scheduler which is currently working in a latest kernel. So you can go like Google Edge also. complete fair scheduler, like this. CFS, completely fair scheduler. So this is a scheduler which is running in a system. So what is the job of the scheduler is to, the job of the scheduler is to schedule the processes. Is to schedule the process. Schedule the process means for every process, a time slice need to be provided. And by default, in Linux machine, the time slice is 1 millisecond. It means that every process will get 1 millisecond of time slice to run. But do you think that the process will get completed within 1 millisecond? No, right? It just started. So what happened? The scheduler, right? It will reschedule the time again. Again, it will be keep giving time. Oh, okay. It is not getting completed with 1 millisecond. Okay, give me. We'll give 1 more millisecond, 1 more millisecond, 1 more millisecond. Like that, what happened, right? Until the process completed job, the schedule will be rescheduling the time slice and it will be giving the time slice to each and every process which is running. But by default, it will always give 1 millisecond as a time slice for every process actually. Whether it's a high priority process or low priority process, any process, right? It'll always give a what? It'll always give you the time slice. Okay. Now coming back to here about the processes. Now these are the different states of the process. It means that whenever any process will get created, every process should undergo all these different states. So sometimes you could see the process is running, sometimes you could see that the process is sleeping, or it is in uninterruptible sleep state, we say. Sometimes the process will be in stop state, sometimes the process will be in a zombie state. And if you make any process a daemon process, you can even convert any process to a daemon process also. Okay. So daemon processes, I will discuss about all these things. Okay. So the first way, what is running process? Whenever the process is running in a system, like here, the process continues running system, those processes will always be having a process state will be R. Here, if I execute the psax command, it is not showing it actually, but basically it will show as R itself. But you could see that here on psax, you could see that it is running. It is actually executed, running. It shows actually R plus means foreground. So it means that this process is running in a foreground only. Okay. So that is what means whenever any process is about to get executed by the CPU, or whenever the process is being executed by the system or by the CPU, those process we call it as in a running state. Okay. So it means that it is occupying or it is utilizing the CPU time slice and it is being executed by the CPU, we say. So whenever any process is not running, right, whenever the process is not running or whenever the process has exhausted its time slice, what the kernel will do, kernel will make that process into a sleeping state. It means that you have to go to the sleep state. So whenever it turns comes, right, the scheduler will reschedule the process and again it will make the process to run until and unless. So when the process is not running, always the kernel or the scheduler will make that process to get into a sleep state actually. That's what you could see. Most of the process in the system are always getting into sleep only. They are into the sleep state. They are sleeping in a background, we say. Okay. So I'm not going in detail about everything, but just in a very high level, I'm telling you. Stop state. Whenever, whenever a process which is running, you want to make forcibly you want to make the process to a stop state, you can either Z the control Z. It's a shortcut in the keyboard. You can either say control Z, control Z, control plus Z to stop the process, or you can send a sig stop signal. How to send a sig stop signal? You have to use kill -19 and specify the process ID PID. So that process specific process will go to the stop state actually. So it means that currently the process has been stopped. It has not been executed by the system. So whenever you need, whenever user need or whenever systems needs, it can turn that stop state to a running state actually, right? So this is also one of the state of the process. Orphan process are under the parentless process. What is orphan process? Suppose, for example, like usually what happens, right, guys, in a system, there will be a process actually running. Suppose assume that this is a parent process. The parent process. Always, whenever the parent process, it want to create one small child process. It want to create a child process. What the parent process will do, it will create a small child process with the help of a fork system call. You know very well, we have learned this. With the help of fork system call, what will happen that the system will, the process will create a child process. So this is the child process we say. This is a child process, and this is the parent process. This is the parent process, and this is a child process. Now what happened? The parent process will delegate the responsibility to the child process, that saying that you please execute certain task. So that will happen with the help of a exec system call. Exec system call is nothing but delegating the responsibility of what parent has to do to the child process with the help of a exec system call. Now what happened, right? As soon as the child gets instruction from the parent that, oh, I need to execute certain task. So child, what will happen that it will be keep executing that instructions. It will be keep executing that instruction. It will be keep executing certain tasks actually. As soon as the child process completes its task, what the child will do, child will send a signal to the parent saying that I have completed a task. And that signal is nothing but SIG CHLD signal, SIG child signal. When it sends the signal to the parent, parent will get to know, okay, child process, whatever the child process which I created, oh, it has completed a task. So it will accept that signal, and after accepting the signal, what happens that this child process will get killed actually automatically. So what happened, right? When the child process is getting created, what the kernel will do? Kernel has allocated so many resources, right, for this process, right? For every process, kernel will allocate, right? Kernel will allocate a memory. Kernel will allocate a PID of the child process. Kernel will allocate all kind of conditional. Kernel will allocate the data style, data block, address block, and everything. It will create a kind of a. It will allocate a process address space, which it will allocate the process address space to the entire child process. Now what happened when the child completed jobs, it has to tell to the parent, right, that I have completed the job. Whatever you have assigned the task to me, I have completed all the tasks. It has to tell, right? So what happened? The child, once it completes the job, the child will internally send a signal, SIG CHLD signal to the parent process. As soon as the parent receives the child receives that signal, what happened at traces, the parent will come to know, parent will deallocate the child process. Parent will say that, okay, you are no longer my child process. In that case, what happened, the kernel will come into the picture. It will kill that child process actually internally. This is how always it happens. Even like when bash is creating a sub bash shell, bash will try to create a fork system. With the help of fork system called bash will create a bash child shell. Then bash will delegate the responsibility to its bash child shell, saying that you please execute the task. So this always happens. So all these processes which are running here, right, there will be some kind of parent and child relation will always be there, correct, in a system. Now what will happen that actually now, so this is how it is normally it happens, fine. When the child becomes orphan process, same thing. When the parent process is there, parent process is creating a child process. Parent process is creating a child process with the help of a fork system call. So this is the child process. Child process. So with the help of a fork system call, parent will create a child process that we know now. And with the help of an exec system call, parent will delegate the responsibility to the child process that you execute certain task with the help of an exec system call. Now child will get to know, okay, parent has assigned me some task, I want to do it actually. So child will be executing that task actually. But assume that child is actually doing some task. It is still not completed its task. Before the child completes its task, assume that parent itself has got killed. Parent itself has got terminated. So now there is no parent at all. Now this child process is completed its task. Once it completes its task, it sends a signal, CHLD signal to the parent, saying that, hey, dad, take the control. I have completed the task, whatever sent. But when it sends a signal, there is no parent at all. Where is the parent? Parent itself has killed before the child. Now what happened that this child process will become a orphan process. This becomes an orphan process. So parentless, parentless child are orphan process, right? Orphan process. Again, what happened, right? In a system, in the kernel, this orphan process will also be there in the system or in the memory for some time. Later, what happened, right? Who is a grandfather for every process? There's a init process which is running here, right? There's a init process which is running, right? Init is the main grandfather for everyone. This init process is running. He will tell that, oh, okay, man, let me take a charge for you. Okay, your parent has killed, no, died, right? He is not there, right? No problem, man. You send a SIG CHLD signal to me. I will accept your signal. So what happened later, after some point of time, init process will become a parent for this child process. Now this child process will get released or it get killed by the kernel or by the system. So till for some time, this child process will go to a orphan state actually, because while sending a signal, parent itself is not there. Parent itself has killed before the child got exited out. So in that case, what happened? The child process will become a orphan process or nothing but parentless process. Okay, so this is what we call it as an orphan process. So if somebody asks you, you should be able to tell the same thing, whatever I explained. Whatever I explained, that same thing you have to tell. Okay. Now, what is a zombie process? This is one of the very important question where everywhere they will ask in an interview also. Okay. Same story. There is a parent process and there is a child process. Means parent has created a child process. So this is the parent process. This is a parent process and this is a child process. So parent has created a child process, correct? With the help of a fork system call. With the help of a fork system call. And with the help of an exec system call, you know very well that it has delegated the responsibility, right? So exec also is done. Okay. Now what is happening that now child will start executing the task which has been assigned to him. So he'll start executing all those instructions which have been assigned to him. As soon as it's complete his job, now this child will generate a signal. You know that it generates a SIG CHLD signal. So it sends a signal to the parent saying that I have completed a task. But sometime what happened that the parent will be busy executing its own task. Parent will be busy with its own task. Parent might not accept this signal which has been sent by the child process. Due to some reason, parent will not accept this signal at all. Or parent might be busy. In that case, what happened that parent will ignore this signal. It will ignore the signal. It will not accept that signal. What signal? CHILD signal. Under that case, the child process will get inside. The child process get turned into a zombie process actually. In zombie process, what will happen that the child process, whatever the resources which are been given for the child process, when it comes to zombie process, what happened that this zombie process will not release any kind of resources back to the kernel. It means that you could know that a lot of memory will be given, some few memory will be given, time slice for the process will be given, even like the PID is assigned to the process. These are kind of resources which are provided for each and every process. For this child process, which now got entered to zombie state, now all these resources will not be released to the kernel space, or it will not be released. Unnecessary, it will be occupying all the resources of the system. Hence, what happened, right? Zombie process will be there in your system for some time. And zombie process will never release any resources. Even the PID, whatever is assigned right earlier, even that PID will also not be released back to the system or back to the kernel. So in that case, what happened? Right? It will be just running like in the background. It will not be doing anything unless it will be occupying all the kernel space or kernel memory, everything. It will not be released at all. So in that case, what happened? That your systems, if your system or in your server or in your real-time server, in your production server, assume that there are so many zombie processes which are there in your system. It means that it will make your system into a hang state. It means that it will make all kind of resources. It will not release. Even for the upcoming new processes also, it will not get any kind of resource from the system because almost most of the resources are already been occupied by all the zombie processes. So earlier in any traditional Unix machine or in some machines like Solaris box or in HPUX or in IBMX, right? Those servers earlier, what happened, right? Lot of sometime what happened now, the server has not been off from last 2-3 years or 5 years. The server will be up and running. When the administrator executes the CX command, right, like this, he could see in a system there are so many zombie processes which are there. So what he will do, he will try to do a kill -9 and specify that zombie process ID. But the zombie process will never be killed at all because Why? Because that you cannot kill the zombie process, because zombie process are nothing but the those processes have already been they already complete job. It doesn't have any existence, but because it the signal what is sent to the parent, because of that reason it was not accepted, right? The process will go to a zombie state. So zombie processes are those processes which are not release the kernel which are not release all kind of a kernel resources to the kernel. It has not released, it is unnecessary occupying. And what happened, right? This child process or which went to a zombie process, this zombie process also will not be attached to any terminal. It will be kind of a running in a background only. It will always be up and running in the background. Okay. So in that case, what happened? If you try to send a signal kill -9 also, those processes will never get killed at all. So what is the solution you have to do? You have to just reboot the server only. So complete rebooting of the server has to be taken care to kill all the zombie process. This is what it used to happen earlier in many of the in many of the production servers actually, because many of the zombie processes used to get created and they were unnecessarily occupying all kind of resources of the kernel actually. So nowadays what happened, whatever you have a Linux, right? Linux will also make sure that it will not keep as many zombie processes in the system. It want to kill all those processes. In that case, what happened for the zombie process also, what happened that you have a init process actually. Init process say that okay, no problem. Even though this process has become a zombie process, let me take care of the zombie process. Let me try to make clear the zombie process so that zombie process will not be there in the system. So init will take care of even the zombie process also. So that's the reason in the real-time production server, right? Nowadays, where Linux is installed or where Linux is up and running, you could see that there are no zombie processes at all, even though your server is up and running from many years. Linux server, right? In the production environment, you will never see any kind of a zombie process which are been there lying in the system. If you execute ps-af pipe it to let's or psix, right? ps-ax, you could see that there are no zombie processes at all in the system like that. So that is nothing but zombie process. You have to say the same thing if they ask an interview. So what is zombie, or we can call it a defunct state also. So those processes are which are not. Firstly, what happened, right? Some of the child process it complete job. They try to send a signal to the parent saying that okay, please accept the signal. I have completed the task. Now, because of some reason, parent has ignored that signal which is sent by the child process, or parent might be busy doing its own task. Under that state also, it might not, or it might have missed this signal altogether. So in that case, what will happen that this child process will get into the zombie state. Where what is a zombie meaning? Real meaning? Real meaning in Hindi, zombie we call it a booth, right? Booth is something like suppose a person is there. He had a lot of wish that I want to do this. I want to do this life in my life. I want to do this. I want to achieve this. Because of some reason, he get killed. He get no he died actually. You know that that person become a booth, right? It means that bodiless soul, right? Bodiless soul means he will showcase that oh I'm existing, but there is no proof that he is there actually. He's alive because his body is not there, only soul is there. It is like his soul is always been will be in air only, right? He'll always be showing his presence that I am there, but actually in reality he's not there, right? He has been killed, he has lost his body. Similarly, what happened, the zombie process will lose his body, it loses existence, but the resources whatever it has been assigned for those process, right, that will never get released. It will unnecessarily occupy and use it actually. So in that state, what happened, the process will get into zombie state, or we call it defunct state. So daemon processes are very important, sir. Daemon processes are those processes which are running in a background. There are some characteristics for the daemon process. First is daemon by default, it itself is an orphan process. It means if it is an orphan process, daemon processes are daemon processes are not controlled either by the terminal, by any terminal, nor it nor it is attached to any parent process. It means that whenever you want to make any process, child process as a daemon process, first you want to make that process a child process. It means that how it becomes a daemon process, first you have to kill the parent process. That's the first characteristic. Second is that daemon process, daemon process will always be running under root privilege actually. Third characteristic, that daemon process will be always working under slash partition or slash root directory. Root directory it will always be working. So internally, how it happens, right? You need to use some kind of a chdar command to change the path of that process to slash partition or slash path like this. If you execute, you can see that if I go man chdar, why it is not there? So maybe we have to install it, or else you can go to the Google. Just say man of chdar, change working directory. So you're changing the working internally. What happened, right? Change working directory or FCA. This is the but these are nothing but this is the command or this is the API to which using by which you can make any process as a daemon process actually. So these are the three characteristics actually. That means that those child process, whenever any process you want to make a daemon process, first you have to make it as an orphan process, and by killing the parent process, that is one thing. Second, that you have to change the root directory of it, and also this child process will not be attached to any terminal. You have to send it, you have to make it under running as a background process actually. You have to make running as a background process. Now, background process, it means that always background processes are those processes which are not attached to any terminal. They'll always be running inside background, in the background actually. So the classical example of all your daemon processes are nothing but all your services in your system. Like you are making an Apache server running, Apache service running, right? Or you are making your DNS server, or you are making a SSS server, SSS service. All the services which are there, right? Those are all those services are daemon process actually. Now you could see that actually, you know that there are many times what happened, right? You want to do some printing operation, right? So what happened that there is one service known as a cup service. Cup service. So this cup service is in Linux actually. So why this cup service are used? This cup service are used for doing some printing operation actually. If you want to do, suppose there's a printer and you have connected your Linux machine to the printer. Okay, what you have to do that whenever you want to make your system having a printer configure, you need to install the cups package actually, like this. Cups package in Linux. So primary mechanism of the Ubuntu printing or print service is a common Unix, the cups actually. So this is nothing but for printing operation, printing service. Now what is happening that this printing, when you install the cups package and all in your system, right? So you can configure your printing operation. Now when you configure it, actually there is a cup services there which are running actually in system. Cup services. Those cup services are not, but those are daemon services only. Those are daemon processes only. So cup service will always be running in a background. You know, daemon service will always be running a background. It will be always be running till your system is up and running. When till your system is up and running, it will be keep running. And those daemon process will always be running and will always give a service to the forcible feature. You don't know, right? When you will give a print service, right? You might give now, or you might give after 10 days also the printing, right? As soon as you do print operation, your Linux system should provide, it should connect to the printer and it should provide the printing, right? So it means that we cannot guarantee, you might need that service at any point of time. So whenever you want to make that service available at any point of time, you want to make that service as a daemon service actually. So daemon service. So what some of the people will say, what is the daemon process or what's the daemon service? Sir, those services which are started during boot time, those are daemon processes. Oh yeah, okay, correct. That is also correct. It means that he is trying to tell that during boot up time, when a system is loaded or when the operating system is loaded, after the operating system completely loads up, what the operating system will do or what the kernel will do, kernel will initialize lot of daemon processes. Okay, so those processes which are always running in the background, we call it a daemon process. Those processes you cannot kill it at any cost. You cannot kill it. See, for example, suppose there is a, if you execute psax -x, so you could see that there are so many processes are running. You could see that so many processes which are having question mark. Those are not but daemon processes. See, you have some process ID 765. Can you kill 765? Just check. I am forcibly killing 765. See? Now again you say PSFNX. Go up 765. Where is it, man? See, this process are 765. Sorry. What I executed? 765, right? Those processes will never get killed. Like for example, you have a PID2 K thread D. Can you kill a process 2? No, you cannot kill it actually. You cannot kill it because those processes are not attached to any terminal. Those processes are running in a background. You cannot send any signal to kill that process. So here what happened, I'm using a kill -9 to, I'm sending a signal number 9, forcibly kill that process, but I'm not able to kill it. Because those processes are, all these processes are Daemon processor. Wherever you see under this TTY, right, under this TTY, wherever you see this question mark, right, oh, it means that this process are running in a background, you have to say. And we cannot kill any process in the background. Like for example, now, yes, hello is running. Okay, I will say Control C. So I'm generating a sig int signal. If I execute a command kill -l, you could see that I'm actually generating a sig. So they might ask you, Rajesh, when you're running any process like this, yes, hello, I'm killing the process with the help of a Control C. What is the signal which is generated? Which is the signal which has been used to kill the process? So signal number 2, sig int signal is used for killing the process. Okay, fine. Now I want to push any process to run in a background, man. How to do it? So no problem, sir. You will say yes, sir, hello, and you have to mention ampersand. Let's say enter. Now actually this process is running in a background, sir. When I do yes, hello, ampersand, you're pushing this process to run in a background. Okay. Now what will happen, that you could see that actually when I come back to this terminal, I'm doing a Control C. See, I'm actually doing a Control C, sir. I'm not able to stop. I'm not able to send the signal at all. I'm not able to see. I'm not able to make this process to kill because this process is running in a background. Now what happened, right? You need to bring that process to the foreground actually. Foreground. So to do that, what I will do, right? I will stop this process actually. So how to stop this process? I'll say Control Z. In the background, I made a Control Z. Stop that process. I stop the process. I know job ID will always be 1. I'll say FG space 1. See, again this process has come to the foreground now. Now I'll say Control C. Now this process will get killed. What I did, I will tell you again. I did a S hello and the ampersand. So I'm pushing this process to run in a background. Now when I do a Control C, see, I'm pressing a Control C button in my keyboard. It is not getting killed. So now, what I will do, I know that anyhow this process is actually running a background, but is throwing the output to the screen or to this terminal itself. Let me do a Control Z. So I'll press Control Z. Oh, it means that when I did a Control Z, this process has went to a stop state actually. Now what happened? I know the job ID 1 because whenever I'm making, see here, whenever I'm making any process, suppose yes hello, I'm not running in a background. I'm running a foreground only. I'll do Control Z. See, this process has stopped. Always, whenever it is the first process, always the job ID is always be 1 only actually. If you execute job commands, you could see that it is saying that, oh, this process is in a queue, but it is having a job ID 1. So now what happened, that I will make that job again run to the foreground by using FG1. FG means foreground. Run this ID 1 in a foreground. I'll say enter. Again it starts running. So now I can say Control C. So now what I did here, guys, I did a Control Z now. Now what I'll do, I'll say FG space 1. Run. I'm making this process to foreground. I'll say Control C. See, now it got killed. Clear, guys? Okay. So now what I will do, I can even make something like yes, hello, or yes, bye, or I'll say yes, hello in a foreground. I'll say Control Z. So it is stopped. And I'll say yes, sir, bye in a background. So this process is running, right? I know that hello is the, I have stopped it and the ID is 1. I'll say FG space 1 and say enter. See, hello is also running. See, hello is also running. See, bye, hello, bye. See, can you make out both the process are running? Bye process is running in a background. hello is running in a foreground, but both are throwing the output to the same screen only. So that's what I'm getting. I can say, if I do control C, hello will get killed. See, I do control C, hello will be killed. See, now buy is only running. Now what I will do, I want to kill even this process also, right? So what I will do, I will do a control Z. Oh, control Z means the process has been stopped. Even though it is throwing a output, it has been stopped. Now I will say FD space 1. Now it is running in a foreground. Now I will say control C. Now it gets stopped actually. I think it is not stopped. Control Z and FD space 1, say enter, and I'll say control C now. Sorry guys, this is not running. It is not coming to the foreground. So let me execute PSAX. So you could see that this process has Y is sleeping actually. So what I can do, I can kill minus signal number 19 to the PID 3508. So I have sent a signal now, and I'll say FG. Now it has been stopped. See, so like this, you can play with the process actually. This is very important, sir. Kill minus L. There are 64 signals are there. Okay. Signal number 19 is nothing but the SIG stop signal. Signal number 17, SIG CHLD, SIG child signal. So this is the same signal which is used by the child process. Child will send a signal number 17 to the parent by using the SIG CHLD signal. SIG SGV, signal number 11, segmentation violation. Okay, SIG pipe signal. If there is any broken pipe, is there, right? Then SIG pipe signal will be generated. SIG alarm signal. If you are using any alarm system call, then the SIG alarm will be used. Like this way, there are 19 signals are there actually. Mostly, so not 19, sorry, 34 signals are there. Out of which there are two signals, SIG user 1 and SIG user 2. These are customized user signal. You can define your own signals if you need it with the help of a signal number 10 and signal number 12. These are all free signals which you can implement your own signal tomorrow. If you want it, you can implement it like that. So these signals are heavily used for the processors to communicate with the processors. The system will in turn use all these signals. Okay. So now, so this is what the different states of the processes we should know. They might ask you what is the zombie process, what's an orphan process, or what's a zombie process in your Linux interview. They might ask you. Okay, guys. So now, so here when I execute the PSX command, you could see that actually the first column is nothing but the PID. Okay, every process will get a PID fine. The second column is nothing but the terminal under which terminal the process is running. The third column will give the stat or state of the processes, whether the process is in a sleep state, running state, defunct state, and everything. Fourth column is nothing but time slice given for every process, and the fifth column is nothing but the command or the process name itself. So these are the 5 columns. Okay, and to get the real-time information about what are all the different processes are running, what is the priority given for each and every process, you have to run a command as a top command. Top is very important command. So in interview they'll ask you what is the to check the information about your current status of the process which are running in system. I want to get the real-time data, how much CPU has been used by the particular process, or how much memory is being used. So in that case, you have to execute the top command. So if you execute the top command, you could see that same PSFNX option only, but here you'll get more information, right? For example, you could see that actually every process will have a PID, and every process will have information about how much CPU percentage and how much memory percentage it is being used, right? That it will show you some information like this. So you could see the system D is using something 00 CPU 1.7% of the memory of the system memory it is using like this. So right now here not many big processors are running. Suppose you are running a lot of big applications you are running through the Java, you are running it actually. You could see that there are some lot of processors like Java processors will be running. It will be consuming heavy CPU and memory in the system. So under that state, you could see that many processors which are running, right, the CPU usage will go more than 100%. So that's the reason you'll get alarm sometime. Suppose you have configured any kind of a monitoring system like Ichinga or Jabix or any kind of a tool, right? It will generate a ticket or it will create a alert notification saying that this particular process has reached more than 100% CPU, or it has reached around more number of memory. Like that, you'll get an alarm. You either you'll get a mail or else a ticket will be generated for you so that you will start working on it actually. So in that case, you will go to that server and execute the top command just to see that what is the percentage CPU it is using. So then you will try to appropriately you will take the diagnostic. Like for example, you might not be allowed to kill the process, right? As a DevOps, you might not be allowed to kill the process. Under that state, what happened is you contact to the developer. So you will say that, okay, boss, your process or this application actually it is consuming more 100 CPU percentage. It is consuming more than 100 percentage, and memory is also it is consuming more. So what the developer will do? Developer will say that, okay, man, you create a thread dump and a heap dump, and share those thread dump and heap dump. We will analyze it. They'll say. So once he does the analysis, then he'll say that, okay, now you can actually stop the process and start the project. Means that basically you try to bounce that application or you restart that application, he will say. So then at that state, you have to restart that application so that the normal behavior will come into the picture. It means that it will start using less. So it will all depend upon the application usage. So the CPU percent in memory, it depends upon how big the application is. If the application is very huge and it is using some kind of a internal no threads it is using, right, or else it might be using a fork system concept to create the multiple char process. Under that case, what happened that the application might use heavily CPU uses. It might use heavily the CPU uses as well as memory usage. Under that case, what happened, the developer will get to know exactly where is an issue with that application. So he will try to fix or he will try to diagnose that issue actually, right? So this is one. There are many process management related commands are there, but I will not tell it now. I will tell you in some other session. Okay, like for example, IOStat, LSPCI, IOMEM, like that. You have most of the commands are there like this. IOStat I have to install, IOMEM I have to install. Like that, there are many commands are there which I'll be installing the package and I'll be explaining you those things. Okay, so right now I'm not explaining those commands and all. Okay, those are some very special commands which are used in our real-time activity. Real-time day-to-day activity will be using those commands. Okay, guys, fine. So any doubts you have till here? No. Okay, guys, I will take another 10 to 15 minutes more because we started the session very late today. So 10 minutes more I will start. I will take it up. Now. Okay, so yeah, and apart from this, sir, I will show you some more commands actually. What I will do, I need to execute some few commands like we have a commands like uh, find command, grep command, set command, awk command. These are some of the important, very important commands which we use in a day-to-day activity. We'll try to learn that now. So what I will do, I'll basically start with the set and awk command. Okay. Then I will go with the find and grep. If we have a time, we will try to complete all the four commands, or else we will see how it goes. So basically, and also like we have a test command also. Test command. So these are all very important commands. So now what we are going to do today that I'll be explaining you very basic thing on set and awk today. Very basic thing. In our upcoming sessions, right, where we have a scripting, right, where we're going to start the scripting. Under the scripting, I'll be showing you set the scripting separately. We have some half an hour session on set scripting as well as awk scripting also is there, which I'll be taking for some half an hour or 1 hour I'll be taking. So there we have a separate big topic in awk script, how we will be effectively using awk scripting and set scripting in our day-to-day activity scripting, right? Whenever I want to write any scripting, I have to use that awk and set heavily I'll be using in my scripting. So that itself is a separate topic at which I'll be taking. But today what we will do, we will try to explain you a very basic usage of the these two commands. Okay, what exactly set and awk does. So set basically, set we call the stream editor. So stream editor means basically it's called the stream editor. Set is basically the basic use of the set command is to replace the string actually. Like in many times what happen, you have a file, there are a lot of words are there in your file. Suppose for example you have words like something like this. Suppose assume that I have a file, I'll create one file by name my file. Okay. I have a file by name my file. So what I'll do, I'll say cat, mat, cat, bat, rat. cat, pat, tat, cat, something. Like this way, you have some string in your file. You could see that there are many occurrences of the word cat, cat, cat everywhere in the file actually. I want to replace this cat word to a dog word. Okay, how you can use it actually? So by using set command, you can actually change the string actually. How you do it? You just set the -e expression, search for cat, replace with the dog, and specify the file name. Can you see that the cat has been replaced to the dog? But you could see that only first occurrence the cat has been replaced to dog, not the second. Here you could see that second more occurrence is the cat that has not replaced to the dog, right? So to make it everywhere, you have to use D globally. So globally, it will try to replace all the cats to the dog. Clear, sir? So this we call it as a replacement of a string. But you could see that actually that if you open the my file, you could see that it has not did any changes to the original file. It was only showing you the output actually. It has not changed it original file. So to make effect original file, I will tell you the option -i option you have to use, but I will tell you later. Okay. So now, so this is one use case actually that I'm trying to change the pattern or the string from one to the other string. So here what I'm doing, I'm using open the code, search for the cat, replace the dog globally, and specify the file name. Here you could see that all the cats have been replaced to the dog. Now assume that if I'm having a file, my file, and assume that this is a uppercase actually. This complete cat is an uppercase. Now, do you think that this cat will be replaced with the dog? Let's see. Set. Now you could see that this cat has not replaced with the dog. So it is case insensitive, case sensitive. It means that here it is only searching for the lowercase cat, not for the uppercase. So under that case, there are two ways you can do. Either you do with the GI. I means case insensitive. Whether it's uppercase or lowercase or combination of upper lowercase, anything, replace all the cats to dog like that. Or else if you're not using I option, if you're not using, then you have to do like this actually. You can use anyway like this. But the lowercase or it's an uppercase. Okay. But this is very difficult, right? So why you want to make, when you have a I option, why you want to make these things and all, right? So people usually don't do these things. They directly go with I. It means that either it's a lowercase or uppercase, whatever might be there, change that cat to dog. Like that also you can do. Okay. So usually sorry, not I option is always used actually, not this method actually. But sometimes you could see that this method is also used to change it actually. Okay. Now here again in the same file. Okay. So what I will do, I will make it lowercase, everything. And here what happened, right? Assume that this cat is not single word, it is attached with some word, alog. Okay. So something like catalog. So catalog is a special meaning. It has a special meaning, right? Catalog, right? So, but the catalog is not just a cat. It is alog. Catalog means it is a different word. Now, if I do a set -e, cat to dog, replace the dog globally. If I do like this, you could see that even that this cat is also replaced with the dog. But I don't want to replace this cat to dog because this cat is not single. It is having a catalog actually, right? So I should not replace this cat to dog. Then in that case, what happened that you want to only search for the word with a cat actually like this. Right? Here you are only searching for the word cat to dog. So all these cats are replaced with the dog, but this cat is not replaced with the dog, correct? So you are only by using some regular expression, what you're doing, you are making sure that only cat has to be replaced with dog. If cat is attached with any other word, don't change that cat to dog. Clear, guys? So here what is happening is that actually here you are just making sure that only that particular word, if a cat is there, that only has to be replaced to dog, not other words. Like here you have a catalog, that should not be replaced to dog. So this is a very basic usage of the set command, right? Okay, we'll move further with the set command. So same file, my file. I'll remove this line. So I'll say, hi, how are you? Hi, something. Set equal to my file. Type to set of. You're giving a line number, right? So set equals to file name, pipe to set numbering, right? So here you're giving line number, but it's not order, right? It has to be something like one hi, two how are you, three bye, right? There are three lines are there. It is not giving it. I can align it properly by giving like this. Okay, what is that? Search for new line, replace with the tab like this. Search for new slash line. What you have to do? That's for uh, search for new line, replace with the tab. Search with the new line, replace with the correct only. Why it is showing you unterminated S character? New line, okay. This new line, semicolon, correct. Here you're having a new line, new line, new line. I'm searching for a new line. Replace with the tab, slash T tab. And not sure, sir. Why it is not working? There is some mistake I'm doing. Anyone has any idea on this? Yeah, like this, correct. So I have missed this slash actually. So here what you are doing that you are searching the new line. So this is a new line. Replace with the tab. It means that as soon as you replace the tab, this hi will come up here like this. Even like this, how are you will come up, and this by will come like this. You are getting it actually. Okay. So here you are giving a line number and all like this. And suppose you have a file. My file is there. You could see the content of the my file. Content of the my file. I could see that it is having three lines there. Suppose you say that Rajesh, I want to delete the first line of the file. Okay, you'll say set the 1D, delete the first line of the file with the name, with the file by name, with in the file my file, right? So when you do it, so you could see that the first line is not there. See, it doesn't mean that it is removing actually. It is actually showing only the output of that command. It is not showing you anything. It will only show the output. This is also very much used. You said Rajesh, first three lines I want to remove it. You said Rajesh said 1 comma 2D. First two lines I want to remove from the file, my file. See, you are removing the first two lines of the file. Only the last line will be displayed. You say Rajesh, whatever number there might be 100 lines of the file are there. I want to delete the last line of that file. So here in this case, the last line is by actually, right? I want to delete it. You will say set the dollar means last line. Delete the last line from the file, my file. See, the last line is deleted. Only the first two lines are only displayed. So set is also used to do kind of a deleting the line, right? Now, for example, you say, or else if you just say like this, set the, you are not doing any operations, sir. Just you are doing like this. See, you're displaying the whole content of the file. So is it not the same as a cat my file? It's both are same only, right? Something like so. Set is also used to display the content of the file also by using this set and the file name. It will display the content of the whole file. It is same thing like a cat command. So D means deleting the line. You have some more options like set the, I think G, specify the my file. In every line, it will show you the spaces actually. In every line, one line, it will show the. You want two line spaces, you set 2G. See, the second line only it will giving you the spaces actually. In the after second line, it is giving one space actually, like this. 2G, 3G, and all like that. So now there are some more options are there. You say that Rajesh, I want to quietly print the first two line of the file. Only two line of the file I want to print it. So what will say cat of, sorry, not cat, sorry, set of 2Q and specify the file name. Quietly print the first two lines. You say that Rajesh, I want to display all the file, all the content. You know, dollar is always last line. So you say set the dollar $2 and specify the file name. It will quietly print all the lines. You say, Rajesh, I want to only display the first line of the file. Quietly print the first line of the file. You're only printing the first line of the file. Now you say that, Rajesh, I want to print it, all the lines of the file, plus I want to print the first line one more time. So I'll say set 1P and specify the file name. You are printing, you are actually printing all the content of the file, but again you're printing the first line one more time. If you say 1, 2P, you're printing the first and second line one more time. There are some use cases are there, scripting where you have to use this P. I will give you the example of where I'll be using the P option later. Okay. So now you have to understand only that P means printing that particular line one more time. You say, now you say, guys, you tell me one thing. I want to print the last line one more time. What you will do? You will just set the dollar $P and specify the file name. You are trying to print the last line one more time. Correct? Last line one more time, like that. So this is some of the usage of the set command, most like editing the file. For example, there is a question will be asked in interview. Okay, these are the if you say cat of file main, my file, you say that Rajesh, I want to only display the second line of the file. I don't want the first and third line. How you'll do it? So you'll say no problem, sir. I'll say set the, okay, I know 2Q, quietly print the first two line of the file. Okay. Now I don't want this. I want only to print this line now. So you say pipe it to set 1B. See, are you not displaying only one line of only this line of file? So I want to print only the second line of the file. In that way, I'm using this command like this. So this is very much useful in our day-to-day activity. We will be using day-to-day activity set command as well as in scripting also we will be using heavily. So I'll be taking a separate session only on set scripting only. Okay. So this is what the set does, sir. Okay. So any doubts you have till here? No? Okay. So I think we will stop the sessions, today's sessions. So tomorrow session, what we are going to do that we will be continuing with the commands for a few minutes. Like for example, I'll be continuing the awk command. I'll be continuing with the find command, grep command. Few more commands are there. I will be like test command is there. So after this, what happened that I will start the scripting actually tomorrow only. From tomorrow, we'll start the scripting. And the scripting will start with the if, then else, if, if, else, case statement. I think with this three, right, I will be able to wind up tomorrow session. And in a day after tomorrow, we will be using the for loop, positional parameters, functions. It's not for loop. You have to see it as a looping actually. In the loops, actually, there are three things. One is a for loop, other is a while, and until. Okay. After this, we have positional parameter, functions. And also a few things, how to comment out the lines uh, in the file, in the script actually. You want to comment out some 5 line or 6 line of at a time. You how to comment out everything. Okay. Positional parameter also will be discussing, as well as we will be discussing about the functions, as well as we will be seeing whether I can able to take the select statement and get ops. So these are not, but this is for the Sunday session actually. And afterwards, what happened, right? We will be explaining the some real-time scripts actually. So this is what the agendas for the scripting class are. So this is very important. I think from 2 to 3 sessions, like from tomorrow, Saturday, Sunday, and one more class, 3 sessions, right? So around 3 to 4 hours, right? We'll be only working on only scripting only. So we'll be seeing various different scripts. We'll try to understand how those scripts work and all, so that it will be very useful. At the end, we will see some 5 to 8 scripts. We will see the real-time script, so that it will be very useful for you guys. Okay, so with that, actually what happened that we will be and also how to debug a script, how to debug the script. Of course, there are few things are there, like for example here, after this I have to even text arrays also, arrays. So this is also some 20-minute session I'll be taking on arrays. Okay, so few things are there, sir. We will be showcasing everything like in the scripting part, as well as most I'll be showcasing the mainly on the SSH connectivity, right? Connectivity, I'll be showing the scripting actually. Most of the scriptings, few of the scriptings, few of the scripts I'll be showcasing in SSH connectivity. Because from one server to other server, you want to do an SSH connectivity, then you want to execute particular task in that new server, in that server. How you can achieve everything with the help of a script actually, we'll be seeing that also in the upcoming classes. So once this completes, sir, once this completes, around for our next 2 to 3 sessions, we can comfortably say that, oh, I know scripting very well. Okay, as well as I said, right, with this actually, with this, sir, with all these things, you will also get this also. So we will be doing about here after loops array, right? We will be showcasing even the sed and awk scripting also here. So this itself will take around 2 to 3 sessions. It will take 3 sessions minimum. Once this is done, we will continue with few more things in the Linux actually. Like for example, your RPM, yum install, yum and DNF. So those are nothing but the it is kind of an installation actually, installation commands. Okay, I'll be explaining you, and I'll be explaining about the partitions, how to create partitions and all. That's what is a swap space, as well as I'll be explaining you about LVM concept. Then we have a separate topic on networking. So I'll be seeing that. There are a few more topics are there, like sir, for example, Samba server, web server, configuring web server, Samba server, and NFS server. These are few topics are there, sir, which we will be covering in a. Once we complete this one, sir, we have almost completed our entire scripting part. These are all small topics, like one hour topic. In each class, right, I can take two topics, and 2 to 3 sessions I can complete the whole Linux session itself. So in that way, we will be winding up our Linux sessions. So maybe by next weekend or little bit one more extra session I need to take in the next weekday class, 1 or 2 class I have to take to finish this complete topic. So next week, I'll probably in the weekdays I'll be completing the scripting part as well as all these other things. Right, by next weekend, before the next Saturday Sunday, hopefully we will be able to complete the Linux session, and we will continue with our Git. Once the Git completes, we will be continuing with our Ansible session. That is my plan. Okay, sir. Hope guys you got it. Chalo guys, if you don't have any doubt, we'll wind up the session. Okay, some of you can stop the session.